It's one thing that has different co-moving sets of organization in it that you call matter.
I think Penny's question ended with, is it a factor of scale? What I'm hearing you saying is that, the Planck level is this very coherent crystalline fundamental field within which protons are aggregates of that at this next scale.
Right.
And the relationships between these are creating these connections.
Right.
That are at a larger scale than the Planck scale. They're still the Planck scale because they're all made of the same thing.
That's right.
And so the complexity is increasing in this sort of fractal relationship of scale,
right,
and relationship of protons and molecules and all the form and physical matter that gets created. So it is increasing in complexity and connection within a unified connected field.
Yeah, exactly. And so, but there's some dampening because the collective behavior again is a slower frequency, right? Right? So you remember on the earlier question, we're talking about, well, why is the proton lighter than the Planck? Well, the proton is oscillating at a slower frequency than the Planck, right? So the, and actually that frequency from the speed of light at the Planck across the proton, by the time it's at the proton and then eventually the electron, gives you the strong force curve. Exactly, right? This is what I show in that paper, right? The range is correct. And when you get to the size of the Bohr atom over there, for hydrogen, you get the exact mass of the electron, right? So that all works together,
That's the density gradient you're talking about.
Right, exactly. Right. It's a angular velocity density gradient. The angular velocity drops by exactly alpha c at the electron cloud. Alpha c is 137 times slower than the speed of light. So, so you can imagine the angular velocity at c at the Planck, very close to c at the proton still, right? But then dropping dramatically very quickly as the radius gets longer, and then at the Bohr atom size, it's the electron mass. And then if you go through a table of element radiuses or radii, then you get the correct number of mass for all the electrons of the table of elements as you go along.